Have you ever wondered what other potentially habitable planets might look like? Do you want to know what planet has the best conditions for photosynthesis apart from ours? Can you imagine a planet almost entirely covered with ocean? What are the closest exoplanets to us that can potentially host life? And are they really life-friendly? You'll find the answer to these and many other questions in this episode. So, let's dive into it. According to the study published in April of 2021 on efficiency of photosynthesis on Earth-like planets in the habitable zone, there is only one planet that comes close to receiving the amount of radiation necessary to sustain a large biosphere, and that is Kepler 442b. It is a rocky planet, about twice the mass of the Earth, which orbits a moderately hot orange dwarf star around 1,194 light-years away in the constellation of Lyra. The planet was discovered in 2015 by the Kepler Space Telescope when it was transiting its parent star. The exoplanet is about half the distance from its star than the Earth is from the Sun. It takes 112 days to orbit the star Kepler 442. Luckily, this planet is non-tidally locked, meaning that there are no extreme contrasts in the surface temperature. The planet is likely to have long days stretching weeks or months in Earth terms. The planet's mass is significantly bigger than that of Earth. Astronomers nickname it Super-Earth, alluding to the fact that it doesn't exactly have Earth-like mass, as this exoplanet is 2.36 times heavier than Earth. Kepler 442b's parent star is approximately 1,000 degrees cooler than the Sun and has only 12% of the Sun's luminosity. Despite this, the planet receives about 70% of the sunlight from its star that Earth receives from the Sun. The star is by at least 40% smaller and less massive compared to our Sun. Thus, it can live up to a span of about 30 billion years or so. For hypothetical life on Kepler 442b, this is good news, as it has enough time to evolve to complex forms. Overall, scientists are optimistic about the existence of life on this planet. According to an index developed in 2015, the exoplanet is even more habitable than Earth. Going to this index, Earth has a rating of 0.829. But Kepler 442b has a rating of 0.836. This is uncertain because Kepler 442b's atmosphere and surface are unknown, but this would be possible. Unlike Kepler 442b, Gliese 667cc is quite close to Earth, being only 23.6 light-years away. Presumably, it is a rocky planet located in the habitable zone of its parent star, Gliese 667c, meaning that it's just close enough to it to have liquid water. A red dwarf, Gliese 667c, is a part of a triple star system in the constellation of Scorpius, with stars Gliese 667a, b, and c orbiting each other, bound by gravitational attraction. Gliese 667c is the smallest star in the stellar system, with only around 31% of the mass of the Sun and 42% of the Sun's radius. Although the star is much cooler than the Sun, reaching a surface temperature of about 3,400 degrees Celsius, and being only 1.4% as bright as the Sun, it can produce enough heat to sustain potential life on Gliese 667cc because it is 8 times closer than the Sun to the Earth. The planet's relative closeness to the star is the reason why it receives 90% the amount of stellar flux received by Earth. The equilibrium temperature of the planet is 4.3 degrees Celsius, or 39.6 degrees Fahrenheit. For comparison purposes, Earth's equilibrium temperature is -1 degree Celsius, or 39.6 degrees Fahrenheit. Of course, this is only a theoretical model, and taking into account other unknown variables, such as the atmosphere and soil composition, The actual temperature can be very different. Gliese 667cc is sometimes also called super-Earth, owing to the fact that it's 3.8 times heavier and 1.8 times bigger than Earth. It takes 28 Earth days for the planet to orbit its parent star. Most probably, the exoplanet is tidally locked, with one side of its hemisphere permanently facing towards the star, while the opposite side is shrouded in eternal darkness. However, between these two intense areas, there would be a sliver of habitability called the terminator line, where the temperatures may be suitable for liquid water to exist. If the planet has a sustainable atmosphere which allows circulation of hot air, the habitable zone would include some areas on the side facing away from the star. Gliese 667cc has an Earth Similarity Index of 0.85 out of 1, which raises our hopes up in regards to the potential habitability of this planet. The good news is, this planet's star will shine for at least 100 to 150 billion years, which provides a lot of time for potential life forms to evolve. Kepler 62e is one of thousands of exoplanet candidates discovered by the Kepler Space Telescope, whose primary mission is to seek out Earth-like exoplanets outside of the solar system. It is located in the constellation of Lyra and has a diameter 60% larger than that of our planet. Its orbital period is 122 Earth days. This exoplanet is believed to be a water world, orbiting at about the equivalent distance of Mercury in its planetary system, some 1,200 light-years from Earth. The planet's nickname, Water World, is no coincidence. A modeling study concluded that Kepler 62e is likely covered mostly, perhaps completely, in water. It probably has a very cloudy sky and is warm and humid all the way to the polar regions, stated modeling co-author Dimitar Sasolov of Harvard University. The hypothesis that Kepler 62e is a water world makes it harder to imagine an advanced civilization on this planet. But there still could be fairly advanced organisms lurking in the water. Kepler 62e has an equilibrium temperature of -3 degrees Celsius or 26 degrees Fahrenheit, meaning that this is how much on average it would heat up from the stellar radiation had the planet been totally black. However, given the fact that the stellar flux of this planet is 20% more than what the Earth receives from the Sun, it is possible that the surface temperature of this planet may be over 77 degrees Celsius, or 170 degrees Fahrenheit, which is enough to trigger the greenhouse effect, which would make the planet's environment hostile for many species. The parent star of the planet, Kepler 62, is a K-type main sequence star that is approximately 69% the mass of and 64% the radius of the Sun. It has a temperature of 4,925 Kelvin and is 7 billion years old. In comparison, the Sun is about 4.6 billion years old and has a temperature of 5,778 Kelvin. The star is somewhat poor in metals, containing about 42% of the amount of iron and other heavier metals found in the Sun. The planet has an Earth Similarity Index of 0.82 out of 1, which is pretty impressive. Earth Similarity Index is the estimate of how habitable a planet is compared to Earth. This number is calculated from the exoplanet's radius, density, surface temperature, and escape velocity, which is the minimum speed needed to break free from the planet's surface. Anything with an ESI above 0.8 may be considered Earth-like. For comparison purposes, Mars scores 0.64, while Venus comes in at 0.7. Tau Ceti F is a super-Earth orbiting Tau Ceti that was discovered in 2017 by the radial velocity method. Interestingly, its parent star is the only star in the constellation Cetus. Being just 12 light-years away, it is the closest potentially habitable planet orbiting a sun-like star known to us. The parent star, Tau Ceti, is spectrally similar to the Sun, although it has only about 78% of the Sun's mass. The radius of the star is about 80% of the solar radius. The age of the star is 10 billion years, although other studies suggest that it is only slightly older than the Sun. The star is not as rich as the Sun in elements heavier than hydrogen, with only 22 to 89% of the Sun's abundance of iron. The star has a 34-day rotation period, which is quite slow. Tau Ceti F's orbit is equivalent to that of Mars in the solar system. The planet is 3.93 times heavier than Earth and is 6.6 times more massive. Tau Ceti F has an orbital period of 642 days. Compared to Earth, Tau Ceti F receives very little heat from its star, with a flux of 0.32 the flux on Earth. The equilibrium temperature of the planet is minus 83 degrees Celsius, or minus 117 degrees Fahrenheit, which is of course too cold for the majority of life forms. However, scientists argue that with the proper atmosphere and a large ocean, the planet's temperature might be similar to that on Earth. However, the new research has shown that Tau Ceti F has likely resided in the habitable zone for much less than 1 billion years, meaning that life hasn't had enough time to evolve and leave a detectable biosignature. Furthermore, the new study, which was published in the Astrophysical Journal, also notes that the star Tau Ceti has much more magnesium compared to silicon than the Sun does. As a result, the Tau Ceti worlds could be quite different chemically and mineralogically from Earth. This was yet another episode in our exoplanet series. Stay tuned to learn some more interesting facts. Please don't forget to like this video and subscribe to our channel.